This is the fourth part of the Tide bottle project. In part 3, we got all the way to the point where we had 1/2 of a bottle surface with all the details for the handle and the label. This part we are going to finish the bottle. We will do so by first mirroring this entire body we have using the front plane as our mirror plane. We'll put a cap on the bottom using a planar surface on the top, and we will knit everything to a solid body. Then we will make a split line on the bottom and use the dome tool to make a dent. We'll add a fillet around the dent, a fillet around the bottom of the bottle, and then we'll add the ring that's at the top of the bottle, and this is a simple solid revolve. Now we're ready, after adding a fillet at the top, to add the shell feature, which will open the top up and shell the bottle to a thickness of about 1 millimeter. Then we can revolve a solid cap and shell that. And I'll just take a cross section of the front plane here. And here we see the inside of our completed bottle and cap. This will all take 14 or so steps to complete, and we've gotten through all the difficult steps in the previous parts, so things should be pretty easy from here on in. So now I'll roll back to where we were at the end of the last video. And that brings us to our single surface body. The first thing we'll do is mirror this using the front plane as our mirror plane. Selecting bodies. And we might as well knit this together. It's not necessary to do so because we have to do another knit later on, but we might as well. So again, we have a single body here. Now we're ready to add a surface on the bottom. Using planar surfaces, all we have to do is click on this edge and finish. Going to the top, we do the same thing. And finish, and now we can knit this into a single solid. So using knit surface, we click on these 3 surface bodies that we have, and we choose try to form solid. Now we see the solid bodies folder is active and the surface folder is gone. Make sure this is the case before you proceed. Now we can add the dent at the bottom of the bottle. To do that, we are going to add a split line. So I'll make a sketch on the bottom. And I'll offset this entire edge inward by 25 millimeters. So I'm going to leave this bottom highlighted, going to offset, reverse the offset, and change that to 25, and go to Insert, Curve, Split Line. And now I can make my dent using the dome tool. It seems to be missing on my command manager, so I'll just say Insert, Feature, Dome. I want my dome to go inward, so I'm going to reverse the direction, and I want to uncheck continuous dome, and I'll make this about 6 millimeters. Now you see we're going to have a dome that goes inward, and it's going to have a crisp edge. If we check continuous dome, it won't have a crisp edge, but instead will start out tangent to the bottom surface and slowly rise up and tangent again. That's not the look we want. Finishing that, we can now add a fillet to this bottom edge, and I'll make that about 3 millimeters and complete that command. Now we want to add a fillet to this outside edge. And I will make that about 10 millimeters, and just clicking on this edge, it should wrap its way around. And I finish that. We'll take a look at that from some different views, and we see because of the bottle contour, the edge of that fillet rises and falls quite a bit and doesn't look very attractive. So I'm going to delete that fillet, and I will make this a face fillet instead. So going to the face fillet option, I will select these two surfaces for my first box, and for my second box, the bottom surface. It still looks the same as before, but I'm going to go down to my fillet options and select constant width. That's going to straighten out that fillet. Let's take a look at that from the front view. You see this looks a lot more consistent going across the side. Still veers a little bit, but it's much better looking. Now we can create the ring up at the top of the neck. So I'm going to make my sketches visible. And on my front plane, make a new sketch. I'm going to copy these elements and this center line that will be used for revolving the ring. So using convert entities, I'll just pick this, this, and this, and finally this center line and convert my entities. I will take the center line and just stretch it across these two horizontal lines and trim away the excess. Turn off my sketches now, and we see what we're left with. Now all I have to do is revolve this using this as my axis of revolution. Remember, this is a solid I'm revolving now, not a surface. I'll leave this merged and complete that command. In retrospect, I could have saved myself one step by not adding that planar surface to the top of this mirrored surface, and instead I could have just revolved a surface that consisted of this top surface and this side here, and then knit that surface to this lower area, and that would have also allowed me to have knit it to a solid. So either way works. My method here took one extra step. The next step is to add a fillet to this edge. Make that about 1 millimeter. And now we can shell the body. I'll choose a shell thickness of 1 millimeter, and I want to exclude the top surface so that this will be open once it's shelled. Now it says here the thickness value is greater than the minimum radius of curvature. I'm not sure where the minimum radius of curvature is, but I'll just say OK, and it has successfully shelled the bottle. Now one thing I did was I added this fillet before shelling, and it's such a small fillet that maybe what I really should have done was added the fillet afterwards. So I'm just going to try it the other way quickly here. Shell 1 millimeter. And apparently that is not what was causing the minimum radius problem. That's okay. So if you have a radius that's less than the thickness of your shell, usually it's good practice to add the radius afterwards, not before. So I did mine a little out of order, but it worked out anyway. I'm just a little bit curious as to where that minimum radius was in this bottle, because that could have given me some problems during the shell. So I'm going to roll back before the shell, and I'm going to use a tool here to check for minimum radius. I'll go to Tools, Check, and I want to check for minimum radius of curvature, so I will select that, and I just click on Check, and it's telling me that there's a minimum radius of curvature somewhere that's only 0.246 millimeters. So let me zoom out a little bit and click on the face in the result list here, showing me that somewhere around here, apparently this little patch I put in has a little area where the curvature is very tight. So maybe this wasn't the best way to patch this in after all, and perhaps the method of using a circle to patch this area in ultimately was the better way to go after all. In any event, the shell worked. Our last two steps now are just to make the cap and shell it. So I'll scroll forward here to where I can see my front layout. Turn on my layouts, and I'm going to just copy some of these lines for the cap. On my front plane, make a sketch. I'll copy this line here, which is where my center line for the cap is located. And I will also copy these lines here. So I will stretch this line up here and just start trimming away. Let me hide my sketches now. And there is my cap. I'd like to have a nice generous radius on the corner here that was not in the layout sketch, so I can add it now. I think about 10 millimeters was probably about right. Check that. And now I can revolve this using this line as my axis of revolution. I want to make sure I'm not merging to the bottle. And finish. Now to shell this cap, I'm going to isolate it so I can easily see the bottom surface. So right-clicking on the cap and going to isolate. That hides everything else. And now I can easily see my bottom surface here. Here's my exit isolate box, which I will use when I'm done with this isolation. And I can shell this, and I will select the bottom surface as my open surface. I'll leave this at 1 millimeter. And finish that shell. While I'm at it, I'll right-click on the body, go to my appearances, and go down to body, and I'll just leave this as a gray color or maybe a light blue color, and exit isolate. And now I have both the cap and the bottle. Let's take a cross section of the front plane here again. We see this is a little odd because the cap is just floating in the air here. In real life, this cap goes down a little bit below this edge, and there's a surface inside that the cap rests on. This surface then continues down from this ring and becomes a pour spout, which raises up into this area. This video isn't going to cover any of that, but if you want to go buy yourself a Tide bottle and check it out, if you successfully built the bottle up to this point, I don't think you should have too much trouble figuring out how to build the spout and these additional surfaces inside. The cap actually extends further down also because that's the surface that has the threads on it. Again, we won't be covering that in this video. So this concludes this video and this project, but there will be a video following this one which will give you a few tips and tricks to help improve the shape of your bottle.